Hello students, this is Dr. Faizan Mirza. I am discussing the details of chromatography with you. What's chromatography? Chromatography basically is a technique in which we use different solvents to separate out the solute components present in a mixture. So the chromatography technique that we have to study includes paper chromatography or thin layer chromatography. Both of them, they basically work on the same principle that you have an inert piece of paper or a glass slide that you cover with a silica gel, and then you spot your mixture of solute on that, and you allow a solvent to move up. As the solvent moves up, as it drags up, it dissolves that solute, it takes it towards the upper end of that strip, and it keeps on depositing the solute components at different distances depending on the solubility of that solute in that solvent. So I'm discussing with you the details of paper chromatography here. So what do? We take, for example, 10 ml organic solvent. This 10 ml organic solvent need to be a volatile solvent. For example, it can be acetone, alcohol, petroleum ether. So we can take either of these. So the organic solvent is kept about 10 ml, and you cover it with the lid, and this is a jar that I have taken. You leave it for 20 to 30 minutes to let the vapor, which is volatile, to saturate the jar. Now once this is being done, parallel what you do, I'm trying to separate out the pigments of a leaf, which pigments are there. So what I'll take a leaf, I'll just crush the leaf in ice cold acetone, and when I crush it in ice cold acetone, I'll use pestle and mortar for this. So when I use pestle and mortar, I can add sand to it to make sure that it crushes very well. Once it is crushed, I'll filter the mixture, and I'll place the mixture here in a separate jar, and this is the capillary tube that I've added here. Now then, the leaf extract is ready. This leaf extract is having the photopigments, the type of you can say the chlorophylls and the carotenoids and the xanthophylls and all. So they are all here. Now these two things are done. Now the next thing I'll do, I'll prepare my inert material. For this in case is the non-reactive paper, and this is just a filter paper. So the filter paper will be taken as a strip. So a strip of filter paper is taken, and at the base of the filter paper, what I'll do from the lower end of the filter paper, what I'll do from here, I'll just draw a line with a pencil 2 centimeters above the bottom of this page. And when I draw the line with a pencil, this pencil line actually will tell me that this is the point from which I'll be taking my measurements from. What I'll do next, I'll take this capillary tube, I'll just swirl it around in the mixture very well so that the components of the mixture get adhered to the end of the capillary tube, and I'll just spot a small sample of the extract on the center of this line. Now once this is done, I'll let it air dry, and once this spot air dries, I'll just repeat this again. I'll spot the same pigment, the same extract in the same way again at the same spot, and again I'll air dry it. So I'll just repeat it 3 times, air drying it every time. This concentrates the spot. So once the spot is concentrated, I know that enough of the solutes have been added here, enough of the material that was present in the extract has been added here. Now what I'll need to do, I'll just combine these two, the third and the first step. Now how do I combine the third and the first step? I'll take my jar, I'll just quickly open up the lid, and I'll hang my filter paper that already is having this solute at the pencil line here in the center, and I'll hang it in such a way that the pencil line stays above the solvent level. This must be ensured that the pencil line which we did draw, at which the solute was marked or was spotted, it must stay above the solvent level. So you hang it in this way, and you allow it to stay like this for 15 minutes. In 15 minutes, you will see the solvent rising up. As the solvent rises up the filter paper, it will dissolve this solute mixture here, and it will start to deposit its different components at different distances depending on the solubility of each solute in that solvent. Now what will we do? After 15 minutes, the filter paper is removed. We'll see a wet mark somewhere at the top here, not exactly at the top, but somewhere at the top, not at the edge. So we need to stop it before it runs to the edge. So I'll see a wet mark here that the liquid actually did rise to this point. What I'll do, I'll remove my filter paper, and I'll start to measure my solvent fronts and solute fronts. Now this is my filter paper, and this orange line that I am drawing is the wet line that I had actually got from seeing how much the distance was traveled by that solvent. So what I'll do, I'll measure from this pencil line which was drawn initially to the line of the line to which this was measured. According to the solvent that actually had moved till here. So what I'll do, I'll measure this entire distance. This entire distance will be my solvent front. Once this is done, I have, for example, these three different solutes here. I have three distances of each solute. So this solute traveled here, the other solute traveled here, the other solute traveled here. So all these three were actually dissolved in the same spot which was present initially in the mixture which I had spotted here. So once the solvent started to dissolve these solute components together, it deposited each of them at a different distance. This is because of solubility. So this was least soluble in the solvent, this was more soluble in the solvent, this was most soluble in the solvent. So the more the soluble substance is in a solvent, it travels longer. What I'll do, once the solvent front has been measured, I'll measure solute front in the same units. For example, I'm measuring the solute front for this solute. I'll measure it from the pencil line from where I did start the spotting to the distance at which the spot has covered. If my spot is oblong or is elongated, I'll take the center of that spot and I'll measure it with the line that initially was drawn as my standard line, and this will be my solute front for this spot. I'll measure each solute front separately. If I had 3 solutes here, so I'll measure 3 solute fronts, one for each solute component. Solvent front stays the same. I'll calculate 3 different RF values. For each RF value, the RF value is calculated by solute front divided by solvent front. They both must be in the same units. When we take, for example, I'm taking the solute front of 1, so I'll divide the distance that is measured in 1 by the solvent front. When I'm using the RF value for the solute 2, I'll take the measurement of solute front as 2, this measurement, and I'll divide it by solvent front, which stays the same. And the same I repeat for the third. I interpret these depending on the solubility, how much soluble the substance is. So as I already mentioned this to you, the RF value is always less than 1 because it's a ratio between solute and the solvent front. The solvent will always travel longer than the solutes. So in this case, if 3 are deposited, these will be my chlorophyll A, chlorophyll B, and carotenoids. So you can see this experiment repeated here in this condition again as well. So you can see how this is done. This is again repeated in the same way that you actually spot it here and you hang it here and you allow the solvent to move. So in this diagram, you can see carotene travels longest, xanthophyll travels lesser. Chlorophyll A and chlorophyll B are traveling even less. So out of all these, chlorophyll B is the least soluble and carotene is the most soluble. So when we are discussing chromatography, what you need to keep in mind, basically chromatography is used to separate the components of a mixture, and they are separated on the basis of their solubility in the chromatography solvent which we are using. Basically, the separation, it depends on the solubility of the solute components in the solvent. That's one thing. Already I have discussed, as higher the solubility of a solute, longer the distance it will cover on that chromatography paper. Different solutes, whichever are there in that mixture, different solutes have different solubilities in different solvents. So more than one solvent can be used for a better separation, or you can also go for doing a two-way chromatography. In a two-dimensional two-way chromatography, you keep the paper vertically first and then you keep it horizontally in a second solvent, and this allows a better separation and even more spots can be seen. That's it from my side. Thank you so much.